Now we are going to start chapter 4 of the series A Brief History of Time. And you can see here is the chapter The Uncertainty Principle, which is written here. And who developed uncertainty principle? What is uncertainty principle? In which branch of physics it comes? And what is the main idea about this principle? So all these things and related topics also we are going to discuss in this video. You can see now starting is here is that Marcus de Laplace, a French scientist in the beginning of 19th century, argued that the whole universe is completely deterministic. By the success of Newton's theory of gravity, he determined that the whole universe is completely deterministic. We can frame we can measure the all the complete parameters of the laws of nature, which is wrong. We know because of uncertainty principle. Uncertainty principle implies that the whole universe is probabilistic at microscopic level, as we know. So uncertainty principle was developed by Werner Heisenberg, and this development was led by quantum mechanics. But how quantum mechanics developed? Quantum mechanics is the branch of theoretical physics in which we study small things. We study atoms, molecules, mathematical theory of particles. And this is the most interesting branch of quantum theoretical physics because it includes many things that you cannot hear, like wave particle duality. Particle behaves like a wave behaves like particle also. These things we are going to cover in this video. And you can see it is the photograph of Marcus de Laplace, but here is written it is the photograph of Pierre Simon Laplace. Maybe both names are same. So you can see it is the photograph of the uh, probabilistic determinism of the universe. You can see it is the wave packets diagrams, and here is the explanation. So all these things about quantum mechanics we are going to cover in this video. First, it was developed in 1900, 14th December 1900, by Max Planck, a German physicist. He discovered that the energy which is light, X-ray, other waves, any energy are emitted are not emitted at an arbitrary rate but only in certain packets he called quanta. In singular it is quantum. For light it is photon. For orbiting particles near nucleus of atom it is electron. All these particles are discovered yet, and this is the beginning of quantum mechanics. You can see is the most fantastic beginning, and here is the explanation we are going to learn about uncertainty principle. But in 1926, a German physicist, Werner Heisenberg, discovered his famous uncertainty principle. And what is that? We cannot predict the exact position and momentum of a particle with exact precision at a same moment. This is the most important principle, which is called uncertainty principle. We cannot determine the exact position and exact momentum of a particle at the same moment, at the same time. This was the explanation of uncertainty principle. And you can see here is the diagram. Here is the diagram to explain how uncertainty principle works. here is the observer, you can see, and observer can observer attempt to measure the position and velocity, position and momentum, either position and velocity. So observer is attempting to measure it, but he cannot measure very well because it is uncertainty principle worked here, that we cannot measure the position and momentum of a particle simultaneously. So here is the mathematical description of uncertainty principle, that the uncertainty in position of a particle times the uncertainty in the um, velocity of a particle is not more than the mass of a particle times the Planck's constant. So this is the mathematical statement developed by Werner Heisenberg. You can see here is the photograph of Werner Heisenberg in this letter, and you can see Werner Heisenberg developed matrix mechanics, which is the first formulation of quantum mechanics, as we know. And here is the photograph of Erwin Schrödinger. And we know Heisenberg, Erwin Schrödinger, and Paul Dirac in 1920s reformulate mechanics into a new theory called quantum mechanics. So how they did? They developed their own mechanics. Heisenberg developed matrix mechanics, his own quantum mechanics. Erwin Schrödinger developed wave mechanics, his own quantum mechanics, and Paul Dirac unified them, both of them, into transformation theory, which is called interaction picture of quantum mechanics. And these are the three formulations of quantum mechanics. And you can see here is the uh, zooming into the soap bubble, and you can see it is the wave crest and trough explained. Here is how they cancel each other, how they um double. And this is the most important thing, which is called two slit experiment or double slit experiment. uh, it was developed by Thomas Young to prove the wave nature of light, which was his mentor's thought. Um Huygens thought that light behaves like a wave. So here you can see is a light source, and light is emitted here, and there is a partition with two slits. If there is a wave behaving nature of particle, so here you can see the interaction interference pattern in this curtain. But if particle behaves like particle, so here interaction interference pattern cannot be observed. So you can see is the interference pattern, and this is due to particles wave nature, and which was later uh, confirmed. And you can see you can also learn about most important thing, photoelectric effect. When light quanta, that means photon, um, um incident into a metal body, that results into the emission of electrons from them. And this was developed by um, Albert Einstein in 1905, we know. And most important thing is that in quantum mechanics, light or any matter particle behaves like both particle and wave, as we know. And this was determined by Davinson Germer experiment. They did the experiment in which they confirmed that light or any matter particle can behaves like waves and particle. This is called wave particle duality, and this was predicted by Louis de Broglie, who was a French physicist. And for that, in 1929, he was awarded Nobel Prize. And you can see here is the most important thing. Here is the models of atom. Here is the Democritus model of atom, and here is the Rutherford model of atom. You can see the electron orbiting the nucleus in a circular orbit, and you can see here is the Schrodinger's wave mechanical model of atom. Wave behaving property of electron, you can see in near to the what you see here is the nucleus, atomic nucleus. And here is the photograph of portrait of Neil Bohr here, who is the most famous physicist ever. And he discovered the structure of atom, we know. And here is the photograph of Democritus. So here is the explanation of uncertainty principle, quantum mechanics, and atomic structure. And here is the most important theory developed by American physicist Richard Feynman, most important physicist. He discovered that the particle would travel in the space and time from position A to position B with every possible path. It can travel with every possible path. So this theory, which he developed in 1948, this is called sum over histories, or path integral formulation of quantum mechanics. So this is the chapter which is called uncertainty principle. This is the all about the fundamental formulations and fundamentals of quantum mechanics. Now in later video we will discuss chapter 5, which is elementary particles and forces of nature. So thank you everyone.